What's up, sports fans and sports nerds alike? I am wearing a wrinkly shirt today. Okay, sports fans, last time we discussed launch angle and that any ball hit above zero on the x-axis there will likely be in the air. But how hard do you have to hit the ball, and what exactly is the launch angle you need to hit the ball at so that it doesn't land in some lame outfielder's glove? That would require a significant amount of force. Yeah, force, baby. That's the topic of today's video. And force is determined as mass times acceleration. All right, so that's the topic of today's episode. Force equals mass times acceleration. That is Newton's second law of motion. The mass of an object multiplied by its acceleration provides us with its force. And if there's one thing that I learned about F equals ma, it's that it is probably one of the most important physics equations in all of physics. And I learned that thanks to my 11th and 12th grade physics teacher, Mr. Dale R. King, the legend. In fact, in our junior year of high school, my friends and I made a physics video, a short film about F equals ma, and you can watch that video in the description below. There's a link. I recommend it. It is Oscar worthy. Okay, now the unit of measurement for force is the Newton. Considering Newton was the one who came up with it, I think that that's mass. We will measure mass in kilograms, and we're going to be measuring acceleration in meters per second squared. Those are the metric units of measurement, and they're easier to use. But hey, I'm not here to judge. If you are a fan of the British gravitational system, then force is measured in pounds force, and mass is measured in slugs. Acceleration is measured in feet per second per second. Anyway, the average mass of a Major League Baseball is 145 grams. Now, if we were to convert that into kilograms, it's easy. We're in the metric system. You just move the decimal place over a couple spots, and you have kilogram mass of 0.145. Now, the average velocity of a four-seam fastball in the year 2019, according to ESPN, links in the description, was 93.2 miles per hour. But that's the pitch velocity. I thought we wanted the acceleration. Let's not jump ahead yet. Let's convert miles per hour to meters per second. I will spare you the math on how to do that. It's 44.66 meters per second. The force that the ball exerts onto the bat is the exact same force that the bat exerts onto the ball. That's the law of motion. And we have too many variables right now. We need to nail down some of these variables. The formula for acceleration is the final velocity minus the initial velocity. All that divided by time. What is time? I don't know. But for this equation, time refers to the time that the bat is in contact with the ball. That little split second. That average, thanks to a study at Penn State, link in the description, is 0.0007 seconds. Okay, so we have a pitch velocity, and it comes in and it hits the bat. The amount of time that the ball and the bat are touching is 0.0007 seconds. Okay, so now we have the pitch velocity, which needs to be negative 44.66 meters per second. Why negative? That's because the pitch is a negative force upon the bat that is trying to push the ball the opposite direction. The ball's exit velocity will be positive. Exit velocity is how fast the ball will move after it's struck by the bat. Negative, 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 positive, positive, positive. Now, the calculations to find the exit velocity are fairly complex. In fact, I could do a whole video just on that. So for the purposes of this video, we are going to find that the average exit velocity in 2019, the speed at which the ball moves away from the bat, is about 104 miles per hour. And again, if we were to convert that to meters per second, it works out to be 46.48 meters per second. So using some fun algebraic manipulations, if we were to substitute our acceleration formula into the variable of a in the F equals ma equation, we ultimately come to this. Force equals the mass times the final velocity minus the mass times the initial velocity, all that divided by the time. All right, so in other words, the force equals the mass of the ball times the final velocity, okay, the speed that the ball leaves the bat, minus the mass of the ball times the speed of the pitch, the speed at which the ball meets the bat. All that divided by the time the ball is in contact with the bat. The force equals 18,857.14 newtons, or kilogram meters per second. Holy smokes, that's an astounding amount of force. It's the kind of force that's gonna break your skull open. That's over 2 tons of force. But what does that mean? What does it mean to have over 2 tons of force applied to a baseball? Well, the ball's gonna go far. But how far? I don't mean to be yelling, but how far? How far? You haven't answered the question you posed last week, Cleat Callahan. You idiot. I know. I'm a real jerk. But if you were to tune in next time, you will get the answer to this question. How hard do you need to hit a ball for it to go over the fence of a ball field? We will hit a dinger. Okay? And we're going to look at things called impulse and sweet spots and how bat speed and exit velocity are not the same thing. That's going to do it for our episode today. Make sure you click that subscribe button. You click a thumbs up. Leave a comment below. If you hate me, please be nice in your insults or at least be creative. Follow me on Facebook at Cleat Callahan, Instagram at Cleat Callahan. Watch me play video games on Twitch at twitch.tv/playbyplay. Follow me on Twitter at Cleat Callahan. This has been Baseball Physics. I am Cleat Callahan, and we'll see you at the ball game or the classroom or whatever the heck it's gonna be. Bye.